In these notes, we're going to review graphs of basic sinusoids. Those are graphs of sine and cosine with vertical transformation. So we're going to have some stretches and shifts. So to begin, we're just going to graph the parent function. So that's y equals sine x and y equals cosine x. To do that, we're going to review a little bit about the unit circle. So I'm going to draw a unit circle here for our reference. And when sketching these graphs, we're going to focus on the angles that go with the axes. So I'm going to focus on these 4 points. I'm going to put the angle measures. We're going to do these graphs in terms of radians. So these are the angles. So 0 radians, the top is pi over 2. The left side is pi radians, and at the bottom we are at 3 pi over 2. And then I want to get the coordinates. Remember, this is a unit circle. The unit circle has a radius of 1. So 0 degrees has the coordinate 1 comma 0. The top of the unit circle at pi over 2 radians, that has a coordinate of 0 comma 1. At pi radians, that coordinate is negative 1, 0. And at 3 pi over 2, the coordinate is 0, negative 1. And remember, the x value is the cosine of that angle, and the y value of the coordinate is the sine of that angle. So we're going to go ahead and we are going to plot graphs of f of x equals sine x. So I'm going to graph that here. I'm going to graph f of x equals sine x, or if you like just using y, that's fine. Always put a scale on your axes. So the x-axis already has a scale. The y-axis, I'm going to let 2 squares be 1 unit, just so I have a little more room. And now I'm going to plot y equals sine x. So when I have 0 radians, I'm at this point, 1, 0 on my unit circle. The y coordinate is 0, so I'm going to go ahead and plot 0, 0. Then we're going to go to the top of the unit circle, pi over 2 radians. That coordinate is 0, 1. The y coordinate is the sine value, so at pi over 2, we have the point 1. Then we're going to go to pi radians. On our unit circle, that coordinate is negative 1, 0. That means the y coordinate is 0. So when the angle is pi, the coordinate is, the y value is the sine value, which is 0. Then we're going to go to 3 pi over 2. This coordinate is 0, negative 1. So that means sine of 3 pi over 2 is negative 1. So let's plot 3 pi over 2, negative 1 on our sine graph. And 2 pi means we've gone full circle, literally. So we're back at 0. I could also say this is also 2 pi. So 2 pi, the coordinate is 1, 0 on the unit circle. The y coordinate represents sine. So sine of 2 pi is 0. And we could also put those coordinates in the negative direction as well. Just rotating, if I were to go to negative pi over 2 would be here. So the sine of negative pi over 2 is negative 1. And now you should remember the pattern from last year. And I'm going to go ahead and sketch the graph. I'm actually sketching 2 cycles here. When you sketch it, make sure you're not sketching pointed terms. They need to be rounded. And put arrows on the ends of your graph. So this is a graph f of x equals sine x. Let's graph f of x equals cosine x. So f of x is equal to cosine x. We're going to graph that on the grid on the right. I'm going to put my scale. So I'm going to do 2 squares is 1 unit. And now we're going to go back to our unit circle. So at an angle of 0 radians, the x coordinate is our value for cosine, so that's 1. So we're going to have the point 0, 1. At pi over 2 radians, we're at the top of the unit circle. The x coordinate is 0, so we have the point pi over 2, 0. At pi radians, the coordinate is negative 1, 0. The x coordinate is the cosine value. That's what we want now. So we're going to have the point pi negative 1. I'm going to plot that. When we go to the bottom of the unit circle at 3 pi over 2, the x coordinate is 0. So we have the point 3 pi over 2 cosine of 3 pi over 2 is 0, so 3 pi over 2 is 0. When we get back around to 2 pi, the x-coordinate once again is 1, so cosine of 2 pi is 1, and this pattern continues with a key point, which is a maximum, a minimum, or a point where the graph crosses its midline every pi over 2. So I'm going to go ahead and sketch y equals cosine x, making sure to make rounded curves and arrows at the end. Make sure that the arrow that you draw at the end doesn't continue off going upwards, because cosine is bounded. It's going to turn around. The same thing on this end. So we've graphed 2 cycles of both sine and cosine.